Give the synthesis of the following alcohol using Grignard synthesis. So as soon as I know it's a Grignard synthesis, I know I will need a Grignard reagent and I will need a carbonyl. Okay, and so it will depend on what kind of an alcohol I have for the carbonyl. All right, because primary alcohols can be made by formaldehyde, secondary from any aldehyde, and tertiary from ketones. All right, so here when I look at this alcohol, this is a secondary alcohol, so it means that I need a Grignard and I will need an aldehyde, okay, for this one. So let's go ahead and get started, okay, and what I'll do is I will go ahead and show you how to do the fragmentation, because when you have an alcohol like this, which is a secondary alcohol, and you have this carbon right here, okay, and so we have to fragment actually on either side of the alcohol. Okay, so we focus on the alcohol and then we look at the fragmentation. So 1, 2, 3 on one side, and then the 1, 2 on the other side. So first focus on alcohol and see if you actually have a symmetrical compound or an asymmetric one. So in this case it's asymmetric, which means that I will actually have two fragmentations, which means I will actually have two different syntheses, okay, for this. So let's go ahead and get started. We'll take each synthesis at a time. So here we have 1, 2, 3, 4, 5, 6. Excuse me, and then we have OH, okay, over here. So what I'm going to do is I'm going to fragment right here, okay, and if you've done fragmentation with me before, then you know that I just like to write my fragments out, which means that this is my fragment and then this is my fragment. Once I have that, then I figure out, okay, what are these fragments coming from? And so when I look at this one, it does not have any alcohol on it. So it means this must be my Grignard reagent. So MgBr. And then the other one, which has the alcohol on it, that must be the aldehyde or the ketone carbonyl. Okay, so in this case, because it's kind of terminal, and also because I know already that I need an aldehyde, okay, so it means that this is where the aldehyde is going to go. Now Grignard reagent you actually have to make, okay, it doesn't come from the store or anything like that, so you're going to make this from this alkyl halide, okay, so which means that these two here are your starting materials, okay, for the first fragmentation. So now we're going to go ahead and do the second fragmentation. So here we are, and the OH here. So now I'm going to fragment it on the other side, okay, and then see what we get. And so I leave the alcohol here, the fragment is on this side, and then on the other side I have two carbons and the fragment is right here. So the left one is the one with the oxygen. It means that that is the one that's going to be the carbonyl. And so here is my carbonyl. Again, because it's terminal, it's going to be an aldehyde, okay, and then here is my Grignard, so MgBr, but then again I know that this is actually going to be alkyl halide, okay, that's where it's coming from. So in this case, this aldehyde and this alkyl halide are my starting materials. Now because this compound, as I said before, was asymmetric, you have two ways of making this, okay, but if your compound, say, was something like this, now in this case you can fragment here or here, it doesn't matter, because in both cases you have a symmetric alcohol, so you'll have symmetric fragmentation, okay. So in this case there'll only be one synthesis or one type of reagents that you need, but in this case you actually have two. Now which one is better than the other? It completely depends on the availability of the reagents. In this case you don't have to worry about if one is better than the other, both are equally good. It just depends on what is available in your lab for you to do the reaction.